Alright guys, we are going to run over just kind of a rundown of the reciprocal functions. Woohoo! Yay! Alright, so when we have our reciprocal functions, this is basically meaning that we have an x or a variable in the denominator. Okay? And the parent function of this is going to be f of x or y equals 1 over x. Okay? And basically, we kind of have an idea of what that looks like, but let's go through it. Our vertical asymptote is where our denominator equals 0, because basically it's saying that your vertical asymptote is the line that your x values are unable to be. So x, since it is in the denominator, cannot be 0. So if we were to set our denominator of x equal to 0, we would have a vertical asymptote right there on the y-axis. And here's what I wanted to remind you. So we have my good friend VUX, which stands for vertical undefined x equals. So I've got a vertical line with an undefined slope because it's an x equals a number. So here is a boundary, an asymptote that the graph can approach, but it will never ever touch. Which means that the x values are limited. X can never be 0 in my domain. It can be any negative number. It can go right up to that asymptote right here at 0. It has to skip over, and then it can go any positive number. All right, my horizontal asymptote is going to be my friend Hoy. And Hoy is a horizontal line. Here, VUX is a vertical. Hoy is my horizontal friend who basically is the limitation or boundary on my y values. And at this point, I cannot plug any number into x that would create a y to equal 0. So my y is going to equal 0. So when I graph that asymptote, it looks like that. It's on the x-axis because y can be any negative number all the way up to 0. It has to skip over that 0 line and can be any positive number. So my y values can be any number except 0. Now, when we talked about this, we were able to put this reciprocal function into a standard form that was very familiar with our transformations. And that formula was a over x minus h plus k. And we knew that when we change a and h and k, those are actually not letters. They just are subbing in for letters or numbers. They're not numbers. They just sub in for numbers. That when those numbers are more than 0 or 1, when a is no longer 1, or when h is no longer 0, or k is no longer 0, it makes the graph change. Oh, I forgot to graph this. So when x is 1, I'm just going to do a quick little table. I'm not going to put it in my calculator. When x is 1, y is 1. When x is 2, y is 1/2. So I'm going to graph 1, 1. When x is 2, y is 1/2, so it's getting smaller. When x is 1/2, y is actually going to be 2. It's getting bigger, so my graph is going to look like that. Then when I do it the opposite, if x is -1, y is -1. If x is -2, y is going to be -1/2. It's basically going to be the exact same graph reflected over here. So when x is -2, y is -1/2. And that looks like that. That's a bad drawing, sorry. But you guys hopefully can get the idea. And if you were to plug it into your calculator, just because I did such a bad job drawing that, 1 divided by x, graph, and there it goes. All right. So now we've got the standard form. When h changes, we know that that's going to be a horizontal shift. When this is x plus h, it's going to move to the left. When this is x minus h, it's going to move to the right. And when I say it, I'm basically kind of meaning this center point. It's going to be shifting left or it's going to be shifting right. This asymptote is going to be shifting to the left or the asymptote will shift to the right. K is our vertical. Oh, vertical. Holy mackerel. And when it's positive, it's going to shift up. And when it's negative, it's going to shift down. So we're talking about this asymptote. When it's positive, it'll shift up, and that'll shift the graph up. When it's negative, it'll shift down, and that'll shift the graph down. If A is negative, the function is a reflection across the x-axis, which means this is going to reflect down to here. This will reflect up to here. So it will flip across the x-axis. When A is greater than 1, it represents a vertical stretch, which means it's going to get long. The ratio between those points are going to get stretched out. And when A is less than 1, it's going to be a vertical shrink. Okay, we've kind of, hopefully that's familiar. Your vertical asymptote is going to be x equals h. Now notice, if I've got 1 over x minus 3, my vertical asymptote is going to be x equals 3. Since this is negative, it's the opposite, and we've kind of talked about that. It's the opposite of that sign. So if I have 1 over x plus 3, my vertical asymptote is going to be x equals minus 3. And one thing that I don't know if you can see that, one thing that we talked about is basically setting the denominator equal to 0. So if that is confusing to you, just say x minus 3. If you were to set that equal to 0, x minus 3 equal to 0, x is going to equal positive 3. Okay. The horizontal asymptote is going to be y equals k, which means whatever k is, so if I have 1 over x plus 4, it's going to be y equals 4. If I have 1 over x minus 3, it's going to be y equals negative 3. So this is not opposite. This is the same. Whatever the sign is in front of that k is going to be what goes in to that equation. All right. Hopefully that makes sense. So let's look at some examples. So we've got 1 over x plus 1 minus 5. So what do you think is going to happen to this? Let's go ahead and write it out like we would normally do. This is going to cause the graph to shift left 1 and down 5. My vertical asymptote is going to be set x plus 1 equal to 0, and I'd be left with x equals minus 1. My horizontal asymptote is going to be basically y equals k, which is going to be y equals negative 5. So now, when I graph it, I'm going to have a asymptote at x equals negative 1, and I know that vertical is my friend Vux, which is a vertical line at x equals negative 1. So I'm going to go to x equals negative 1 and draw that vertical line. Horizontal is my friend Hoi at negative 5. So 1, 2, 3, 4, 5. So my domain is going to be basically all at negative infinity all the way up to this vertical asymptote, which x cannot be negative 1. It can be anything bigger. Y cannot be negative 5. So then to graph it, you're going to go to your calculator. One divided by, I'm going to use my parentheses, x plus 1. I'm going to close the parentheses since I'm no longer in my denominator, minus 5. And sure enough, you'll see that that asymptote moved over to negative 1 and moved down 1, 2, 3, 4 to 5. So you can graph a couple points from your table. I've got negative 2, negative 6, so negative 1, negative 2, and then negative 1, 2, 3, 4, 5, 6. And that's about it for whole numbers there. That's going to fall right along that asymptote. Then my negative 1 is going to be my asymptote here. 0, 4, 0, negative 4, 1, 2, 3, 4. And we'll see, I don't think we're going to get another one. It's going to look a lot like that. Same type, oops, let me move this over here. Notice that it's basically the same graph. It's just that this one has moved down and to the left. Down 5 and to the left. Same basic shape of the parent function graph. Okay, one more. This one's going to be reflected with a negative and a stretch. So let's write that. It should be a reflection. It should be, excuse me, a stretch by a factor of 2. And it should move left 3. Excuse me. So my vertical asymptote is going to be basically x equals h, or where x plus 3 equals 0. So x is going to equal negative 3. So let me go ahead and plot that. X equals negative 3. 1, 2, 3. That's my friend Vux. And then my horizontal asymptote is going to be, there is no k. This is where y equals k. Well, in this situation, k is 0. So y would equal 0. So my asymptote is going to be right on the axis, on the x-axis. My domain is going to be x is the set of all real numbers where x cannot equal negative 3. and y is going to be the set of all real numbers where y cannot equal 0. And that's going to have basically similar shape, except we're going to see what that stretch does to it. So let's see if I have y negative 2 divided by parentheses x plus 3 and a parentheses, graph that. So it does look like it shifted over, and it may have gotten a little, oh, you can't even see that, sorry. Ta-da! And let's see what the table looks like. So, goodness, those are some big numbers. We've got 1 and negative half, negative 1 and negative 1, negative 2 and negative 2, and that asymptote. So it stretched it by a factor of 2, so it's no longer just at 1. And let's see what's happening here at negative 4. 1, 2, 3, 4, 2, and negative 5, 1. So same type of graph. Now look at this one's reflected. So that means that this is now flipped down onto this one. This is now flipped up into that quadrant. Hopefully that helps.